Hi everyone, good morning. Welcome to Coreflux Cracked. Today we have a full day with a lot of fun, technology, and we will also talk about a lot of MQTT. In the morning we have a morning session with training and deep diving to our platform. Obrigado, passo a bola aqui bocadinho ao Hugo.
Sim.
Thank you, have a nice day.
Okay, so thank you, Gilles. Thank you everyone for joining in. Those that are online, actually on the link I can see them over there. You also can see them over there and the ones on the room. I want to start by first doing a wrap up about MQTT. We're just going to start for those that already know MQTT, it's going to be a 15-minute time window just to clear out and to put everyone on board of what MQTT is all about. The MQTT protocol was actually built for a pipeline in the 90s by two guys, one from IBM and one from, actually both were working on IBM at the time. And the idea behind it was to have something that was able to provide signals from electric valves for a pipeline not of data but of petrol. In the end, it was a 500 miles of pipeline, so there were a lot of sensors, and with typical cabling you're not able to exchange data. So they needed to use at the time the internet, or what was the internet at the time, which was simple telephone and wiring. So they created something that was able for every node, let's say on every X kilometers, to use the telephone network to provide data into a central broker. So they created the first MQTT broker at the time. So they needed to create a very low bandwidth protocol that was able to separate data into topics, so something like a directory of information, and every client needed to provide information like if the broker was a PLC. So the idea was that they were able, all of them, to provide inputs and outputs into one central node, which was the broker that was somewhere in the middle of the US. Kind of worked, and with that it was created the first MQTT broker and the first data pipeline. Years went by and it reached the point where IoT appeared and Industry 4.0, and the protocol in the end became the go-to standard for the manufacturing and energy sector. So we kind of have a solution where we have multi-clients, and those multi-clients are able to publish and subscribe data at the same time. What does this mean? It means that you are able to publish information into the broker, and at the same time you are able to subscribe. So everyone is at the same time sharing data between each other. In a sense, for a manufacturing process, you are able to put one broker with two PLCs and you are able to exchange data with those two PLCs, and they are not physically connected. So you're not using physical connection between both. But you can also put a database that you are able to exchange to MQTT or any other given system. So it's a place where you're able to change signals. So that's the definition of an MQTT broker. And the pattern that it uses for that, it's events. So instead of having something that's all the time like pulling information like a typical manufacturing protocol is using, it's always saying, what is the signal 00, what's the signal 00, what's the signal? So it's always asking a normal like a Profinet, like Ethercat. MQTT doesn't. So we ask to the broker, please inform me when the signal 0.0 changes, and then it becomes silent until something occurs. And this kind of lowers the necessity of having a lot of requirements. So in a sense, it's something that it can actually achieve the point that you are able to connect multiple devices, multiple systems, and you're not consuming the bandwidth of your plant. So how does this kind of works out? So the typical topics that we have over there, they are divided into an hierarchy. So you're able to create something like sensors temperature, room 1, room 2, room 3, room 4, or you can create sensors pressure and then valve 1, valve 2. So you're able to divide in the way that you feel fit. So you can adapt to your use case. So if you have a factory, you will probably have factory, line, machine, and then whatever you have inside of the machine. And at the same time, you can have factory, line, and your manufacturing execution system, and you can put both working together. Usually when you define a publish and a subscription, you're able to do it in a way that you have wildcards. But for that, I will give you a small example. So if I go here, this is MQTT Explorer, so I'm going to disconnect. I already have a broker. If you have it in your computer, if you followed at least, I don't know if everyone has received the document or if they installed the Docker, we can follow through. I will try to go step by step, and you can try it in your computer as well.
Just 1 second. There may be a glitch in the document that you received. If you need to download Coreflux and you cannot click, just go to coreflux.org/downloads and you'll find it there. Sorry.
So basically you can try it. So the idea behind this is if I'm able to run, so if you run a broker, let me just connect. I have one already here. We are able to see that once we start to connect, and usually the password for Coreflux is root Coreflux. So it's very, very straightforward. You are able to connect to the broker. And in order to show you this, I will just do a small demonstration here. Let me just stop sharing because the share is not on the screen. Okay, now you are able to see. Yes. So let me just connect again. So root Coreflux, you're able to do this. So this is one MQTT Explorer that you can use. I will show you another one that we have. So if I publish like this, factory line 1, machine 1 and status, and I'm putting not okay, and machine number 2 with an okay, and a machine number 3 with okay as well. You get the idea. We have, let's say, a structure of information. So the idea behind this is that you divide your, let's say, your business case, your use case into each topic, so you can add information at the side. Like for instance, if I have another line, let's say line number 2, I'm able to have this type of hierarchy. So you can have, let's say, a mix of information. So this is what we call, let's say, the beginning of a unified namespace. So a place where you're able to divide your information based on an hierarchy. And this enables you with a special wildcard, which is the one that I was showing, which is this single level. You're able to subscribe only to that specific information. So what does that mean? If I go here to this broker, I'm able to remove what I'm subscribing. So I'm subscribing to a wildcard, but I'm going to do something which is going to fall factory plus. So I'm going to put this plus, and I'm going to write down machine 1 status. What I'm doing here, the idea behind this is that I want to subscribe to every line that has machine 1 status. It's not a typical example that might be fit to a use case, but I just want to prove the point that we are able to only subscribe to what we need. If I try to publish right now this information, you will not see anything because you're not subscribed to that information. The broker, if I publish factory line 2, machine 3, doesn't follow the rule. But if I put machine 1 and I publish, we have the message coming back. So this is also a way to query the information that we need, just to focus on the specific topics that we really want. And this is important for the rest of the things that we are going to show you regarding the part where you are able to orchestrate this data. This is the way you typically use it. It's with the wildcards. Because if we want to define that of something that only works for every machine, if it's on factory 1, 2, or 3, or 4, or line 1, we need to define with this wildcards. So another wildcard that we have, it's this one. with this wildcard, it's not hashtag, it was gone, but nowadays everyone calls this a hashtag, but it's not an hashtag. Some of us actually call it tic-tac-toe, which is the game, but the idea behind this one is that it's like like you're making a directory. It's like the one you are searching for a file, you're able to search for all the files. So if I subscribe using this wildcard, every time I publish anything at all, I'm able to get it. So, and we can use that as well in a place that we have already a rule defined. So if I do factory this one and I remove this subscription, I will only get everything. If I try to publish test, it will not work. But if I publish factory /line1/machine1 status, we are able to get. So in a sense, it's a way to subscribe to everything. So this is just a quick recap of MQTT. Not going to follow more on this. I'm going to focus now more on what we are bringing with the broker, with the language of things, what we are able to set up with our LoT notebook, which it's more important. But this part, especially the wildcards, are quite important because it's the way we are able to use, let's say, a mechanism to create common functions. Like if I want to have one action to process, like a method, for all my given temperature sensors, I'm able to use this wildcards. Quality of service. This is something that I will quickly recap, but in a sense, when you're publishing with quality of service 0, it's like fire and forget. You just publish and the broker doesn't provide any feedback to the other subscribers that are receiving. But if we use quality of service 1, it will actually work in a way that the one that publishes will wait for a reception that it was received. Basically, if we are working with PLCs, I recommend this one, not to stop the PLC by collecting any information. If we are talking about picking up data to a dashboard or to a cloud, let's say, I will definitely go with quality of service 1. If you want to assure that there are 3 or 4 brokers across, let's say, a given geography, you have one in Portugal, another one in Italy, or another one in any place, quality of service number 2, it's the one you should go for a bridge, for instance, in order for them to be able to share the events between themselves. So this is at least a way to better use the levels that we have for the quality of service. So Coreflux, we have actually 4 components. So we are built on top of the MQTT broker. So the MQTT broker is like the baseline, the standard. In a sense, you could have used another broker. You are able to get user authentication like you have on the broker, but with an additional part. You are able to run rules that are connected to, for instance, your client IDs or the certificates. Second, you are able to also run logic. You are able also to transform that information within the broker. So the broker kind of picks your raw data and transforms into, for instance, a JSON file. And that JSON file can go through a route, which is connected to a database or to any given other system. In the last but not least, you're also able to run Python methods that can go through something simple like methods that are adding numbers to running, for instance, a machine learning model like YOLO, which is a vision machine learning model. So you're able to detect objects. We kind of are building our solution on top of the broker, so we are not just a simple MQTT broker. So for the manufacturing sector, we have what we call industrial routes, where we exchange from Ethernet IP, ADS, Siemens S7, Modbus into MQTT, and even OPC UA. And then we have the database pipelines. So we have other types of routes that you are able to exchange to database, and we have REST APIs. So the broker has a lot of features. And I'll not go through this because that's more a commercial part, but in the end, this is what you're able to get. So you have on one side the connectivity part, and on the other side you have another connectivity part, and you have the broker in the middle that's kind of transforming the information into, for instance, a database, or to even simple system like Slack or Teams where you're able to send a notification. It also depends on what is your use case, what you want to do. If it is something that you need for measuring equipment efficiency, or just a basic notification messaging system, or just a dashboard in Grafana. So clearly depends on what we want to achieve. So this part that we have built on the broker uses in a sense what we call commands. So we started the broker, the programming part of the broker, with commands. So the broker is able to do stuff remotely, let's say, if you have a root user, which is, let's say, a sysadmin of the broker itself. So there is one topic, which is a system topic that is able to handle commands. And that's the first part of having the broker to enable the broker to run any operation. The sys topic, it's a specific topic that only the root user is able to run, has this type of topics that we are able to handle. So we have the command, which we really are able to send a command. It's like a terminal, like a shell. You're able to send commands to the broker, so the broker readapts and changes. And we also get what are the actions, what are the routes, what is the configuration, what are the models and the rules. And I will go through those. But this is the sys Coreflux topic. Just to give an example, I'll go yet with the MQTT broker. I will connect with root Coreflux. If I connect with another user, I will not get the sys topic. Probably also I have the wrong subscription. Let me just put it. So I also need to subscribe to that one. Usually it's like this, sys/ and the cardinal. So I will add, and I will connect with root Coreflux. If we go now, we'll see two things. One, my machine is running with Linux, so I'm able to see all the connections that since I'm using Docker, inside the Docker it's a Linux container. So I'm able to see the comms of the Docker itself. And we also are kind of grabbing the Python that is running inside. So we check if Python is running or not, and we kind of attach ourselves into that one, to Python. So with Coreflux we have, okay, that's a license. In this case we don't have. Then the version, the Docker one doesn't provide the feedback, it's the latest. Usually that's on the Docker itself. Then you have the config, where you can see all the configurations and all the rules as well. And I will go through this in a while. If we have models, if we have routes, if we have actions. So I have a lot of stuff running on the broker. And then we also have if we have Python scripts. So sending a simple command, for instance, we can test this, is sys coreflux/command. And we do it just a simple -h. And if we go here, we get an output of the command. So the -h is like a help. So this is all the commands that we have internally. And why this matters? Because all our UIs that we have actually two that are already running, one for Visual Studio Code and one for that's running inside of the broker that I will show it after. They all use these commands. And if you want, you can also create your own CLI, your own client. You can run it by yourself. And if you want to somehow fix something, you can use an MQTT Explorer or our own MQTT and send the command by hand. It's not practical, but this is just to understand how we are injecting and removing data from the brokers, how the UI is working in a sense. So you know what is happening on the background, let's say. This is an important note in order to test. We need to subscribe to sys topic, otherwise it doesn't work. as I shown you, but kind of the commands are here. So the most important ones. So in order to add an action, we have add a new action, and then we need to specify the code. Remove action, we just need to specify what is the action that we are running. But again, this is running internally. This is just to see how Coreflux is reacting to the broker. So in a sense, it works like this. So what is actually happening if I'm sending an action? I will do something like this, and I'll go through afterwards because this is already language of things. That's the language that runs inside the broker, and I'll go through it again. But this is an idea of what is happening inside the broker with the commands. So that's how we deliver. We needed something inside the broker, otherwise the broker was just a commodity, to really create a way to help out the customers in order to have a simple way to integrate and to define an architecture. Usually if you look at a typical IoT architecture, you will have something like either a broker or a server in the middle, then you have something that needs to connect to the device itself and transform the information, like an agent to collect data from, for instance, a PLC. That agent could have been done in an old red instance or something that at the same time will transform information, then injects the information to the broker. Then after the broker, you have something that transforms that information into something that is able to ingest to a database. And then the database is not able to fit all in one shot, so you probably need something like Kafka. And in the end, you end up having a huge architecture that you only want to register the counting or the alarms of the machines, and it's hard to maintain. And even if you want to change anything, the only way to change is that you have the full picture and you know what is running or what is not running. Our idea is to put an abstraction layer that you are able to build that into one silo, and it becomes like the single source of truth. Not to create a lot of softwares, to have something that is there. It's a broker, it's able to handle data, it's able to handle the through output, it's able to run the methods, it's able to coordinate those methods. And if you have a database, okay, the database has a function to store data and to query the data. The PLC needs to control the machine or the equipment, so everyone has its function, but on the middle one, that architecture is translated into one component. That's where we are going, that's the direction we are taking. So we created 4 things, let's say, 4 components that usually you will find them into a typical architecture. First of all, starting with the actions, because it's the most simple one. Actions are things that kind of act upon any given stuff. If it is on time based or not topic change. So if a topic changes, the action will run. If it's based on time, on every 10 seconds, it will also run. So in a sense, it's a way to run logic within the broker. Models, you can see as models as, for instance, they can be translated into CSVs or into JSON. It's a schema in the end. So imagine you have raw data coming from the PLC and you want to send information. If you have something that says true, false, and if it is a sensor, and you know that sensor is when you created a part or you manufacture a part, you probably want to create a message that says machine number, timestamp of the moment that the part was done, what was the recipe. So that's a model, that's a schema. So it collects information from raw data or any given action or other source of data, and it kind of joins everything into one shot, and it kind of is the picture of the event of when that happened. So this is a model, and they actually work with the routes directly with database. If it is a database, you can write on a model to say to store in that route. And if it is an SQL or a MongoDB, the model will cover that automatically. You don't need to do anything. It goes. Let me start the routes. The routes, the name I think is self-explanatory, so it's how you flow the data. So we can have a route for an S7 PLC, we can have a route for a database. And each one of them has specific parameters that we need to define. We can define for a route, each route will have its own schema of requirements. A PLC probably will require a port, a database as well, so it's a bit example, but for instance, an S7 needs rack and slot. It's very specific. You are able to add that to the route if it is of type S7, so it kind of works as a, let's say, as a template for each one of the device, and it translates. So it's like a connector in the end. And they are connected to all of the other logics that we are running. The rules, it's what we use for permission control. So you're able to define a rule that acts upon publishing. You can say that only this client can publish on this topic. It's like if you have, for instance, a robot, that you only want the robot to be the one publishing on that specific topic, you only say that only this client ID will be able, or with this certificate, will be able to publish on that topic. That way you know that it's not any other given system that is publishing, but the other ones can subscribe. But at the same time you can say, no, this one cannot subscribe to this topic. So you are able to define in a granular way what system is able to communicate with that one, with data. Basically, this is the syntax that we usually use. So we have the define, the component, the name, some options that are available, and a configuration. So our language is the domain-specific language for Coreflux, but we want to go through more in a journey that kind of redefines what MQTT is all about, because being on board of the standard, being present on MQTT.org, kind of for us, we need to do something that's different, because MQTT is kind of, in this new era, is kind of stuck on version 5, and nothing has changed it yet. And this is what we are bringing into play, which is a different solution. So I'll show, so we have this, this is our broker communicating. I'm going to start by opening, so this is what we call, this is VS Code. So you can download it on Microsoft, and we kind of attach it ourselves here for two reasons. Since our language is very similar to English, we needed to create a way that you are able to create one project, because as you can see, we have actions, they are kind of spreaded. So they are like small methods that are kind of lost. And if we use our own new AI, so if I go to our UI of the broker, which is this one, where you are able to check the topics that we have. I can check this topic. So we have the topics here the same way. So it's an MQTT Explorer. So let me just put it here. But we also have the LoT editor here. So I already have a couple of models. I will erase them, but you can see them here. I can actually use them, and I'm going to erase them all. But if I need to create one, I'm able to create here. So I'm able to create an action within the broker by using the UI. So it's something like define action test on every 1 sec. So what I'm building here, it's an action that will run on every 1 second. I will put something there, but I could have copied this into the broker, define one, and I will not have, let's say, a project by itself. I will not be able to control this. I will have to store it in a document file. I will have to store it somewhere. So we kind of created, that's why I was showing this. So if you go to VS Code, and if you have VS Code, you can download the extension LoT Notebooks. So it's similar to a Jupyter Notebook. If you don't know what a Jupyter Notebook is, it's like you have text and then you have code. But in this case, on Jupyter Notebook, it's Python. Ours, it's LoT. So the idea behind it is that you are able to describe the system. So I describe the training here. So we have simple, this is a markdown, so this is text. And I'm able to go to the first layer, which is the timed actions. And we have text explaining. So you can imagine if you are doing this, this is the second file. Let's say if you see here, it's a structure. So it is a project in the end. You can build a project with any given component. And this is where LoT comes in. So this is where we have our first logic. In this case, I created a simple heartbeat on every 51 seconds. I probably need to change this. I will change this to on every 5 seconds. It will provide and publish a topic saying alive. I'm able to connect to the broker by clicking here, and it asks for the authentication. So I'm going to use only the sysadmin is able, the root user is able to publish by default on a broker. So I'm going to use the root user. You can create with the UI other users. So you can go to the UI, which is on your computer. You just, if you use Docker, you are able to get the UI. You are able to add users or remove users. But if you use the Linux image, you probably you should install the Docker in order to have the UI, and then you can access the Docker and the UI and connect to any given broker. If I go here and disconnect, log out, I'm able to specify the broker that I want to connect in order to control. In my case, since I'm using localhost, it's the one on the Docker. So if it is, imagine, another IP, you can use the other IP name if it is under your network. So the same happened here. I already connected to the broker. So I was able to click over there. It appeared over there that I needed to connect, and a new tab opened, which is Coreflux entities over here. And this only has rules. So on my broker, I only have rules running. I don't have any action. But once I click here in this one, a new action is downloaded to the broker, which is this one. And if I go down here, I press play, I can see that I already have the topic system heartbeat. So on every seconds, I'm writing, the broker is writing within himself system heartbeat. And we can see that this is synced with a notebook, and it's a very similar situation like a PLC. If you right click, you can copy the code, you can update from the cell to the broker, or you can update from the broker to the cell any given way. If I click it, it will line up where in the document is. So if I'm like in here and I double click, it will go to the document where this action is installed. So you are able to sync in with your project. And the concept here is to describe how the integration is done. So imagine if you have something like the one that I was saying, like a simple machine that is counting the parts to a database. You probably will have the database into a LoT notebook, into one file, and then you have the machine on the other file, and you create the integration on that file, and you create the one on the database for another one. Why? Because maybe one day you want to add a second machine, a third machine, a fourth machine, and maybe those machines are similar. So you only have one file by using the wildcards, for any machine that is similar or equal, if you build a machine on the same way. If they are different, you probably will create a second file. So the idea behind this is to create a project. And since we are on VS Code, you already have Git, so you are able to create your version control, so you're able to upload, you're able to download, and anything that happens within the environment of VS Code, you are also able to achieve. And for instance, if I go to this one, we already have the alive topic. So it's running on every 5 seconds. So we don't need to open, we also have it here, so we know it is running. So I will be kind of working most likely here during the training. So I will not cover anything. So we can go a little further. We also have entities where we are able to provide more contextualized data. So something like the timestamp when this action occurs. And we can put it into, so this, you can see it as a method. So the broker translates timestamp into a method that you want to run that's already native on the broker, and that you want to provide the timestamp on this particular moment. So if I upload this action, means on every 10 seconds, we will publish system time UTC with timestamp UTC. So in a sense, we'll get this. So this is Unix, which is the one below, and UTC is the one on top. You can also define a schema, how you want, if you want the day, if you want the time. We can check it on under our documentation. So this is something that you can check all these concepts here. So if you have any doubts, you can check our docs. So it's docs.coreflux.org, where we have these entities already written and structured. So another example, like the one finished one. So imagine that I want to use something that counts every second. And this is the place where you start to understand how the broker works with data. So I have here a topic, which is counter value. And what we are doing here, we are getting the topic counter value and we are adding one. So the action runs from left to right, let's say, from up to bottom and from left to right. We only have one line of code, which is publish topic. So, but in this case, it works like a PLC. It collects all the topics that happen on that moment it was running the action. So it kind of takes a picture of the inputs, it processes the code, and then it outputs the result. And every time we have publish, it means that this action needs, in the end, to publish this information. So after it runs, it publishes this topic. So if I add this one, we will have something like a counter that's running every second. This, I usually use the timed actions to explain the LoT as a beginning, but it's actually more useful, this concept, when you're using other topics. Why? Because if you're using something like a sensor that needs to publish a true on the moment something occurs, and you need to collect a lot of data and create a JSON like a picture on that given moment, the broker is able to do that. So on the moment the variable changes to true, it collects all the information for that specific topic, and it becomes a real-time system, and you're not getting data that's from different time moments. If you have an old red or a Python connected to the broker, you're not able to do that because this is running within the broker. So the broker has the memory of all the data. If you have something that's external, you connect, you collect the data one by one, and you don't know if on the moment that the variable changed to true, if the order was correct, if the barcode was the right one, whatever. In this case, you know, because the picture was taken on the moment it was running. So you get the JSON with the right synchronization in the end. So we run we are able to run 800K message with 0.5 cores, 800K, but with a given length. The guys from NOAA were able to show us that we had a lot of data points and were able to handle a lot of data points, but 64 bytes, let's say, we're able to handle 800K message on half a core, so that gives a lot of events. So we don't work on the millisecond scale. We are working on the nano, because it's event-driven. The PLC, it's forced to cycle a specific code, and it needs to maintain that specific cycle. We don't. We are always waiting for something to happen, and we act upon the moment we get a trigger. And LoT is actually using that mechanism the same way as the broker in order to do that. If you have your computers, and if you have already the broker, we can start doing some small exercise in order to define something. So I will do one. So I will write define action. The code VS Code already understands what I want to do. So it's very easy for me nowadays to be able to work. So he already knows what I want to do. I just hit tab. So basically, if I need to answer something for every 3 seconds, I can do it like this. But we have a couple of ones here. So we could have used it, for instance, every 3 minutes, every 3 days. So you can have something that kind of acts on a given moment if you need to, for instance, stop something on a given day, because you can define on, every, and you can specify 10 hours. So at 10 you do something, or at 6, or you can have something that runs, for instance, every year. Just someone asked me that and I was like, I don't know how I can validate that. Okay, so that, but it kind of worked. We were able to validate it works. So you are able to create actions that are timed. So these are very simple actions normally, but we have other ones that are a little more complex. Let me just go up. So you can see even that here the document itself is interactive. I can go through next. So you're able to build like a web page. And this works as the documentation for the system, which usually is an issue on any given system that we build, and at the same time is the code. So our idea is to have what we call system as a code, where the system is described and you have a way to describe the system, and you're not kind of making small codes spread that in the end you look at your GitHub and you see a lot of repositories and you don't know even which version is running. In this case, you know the version because you can check if it is similar, if it is equal, and at the same time, since it's very close to English, you can understand what is there. And with someone from not a technical person, someone like an industrial engineer, you're able to explain, for instance, this is the process change we are doing. So we are running on this particular moment, and you can describe on the documentation, and it's a way to sink in. So it's a way for you to have something that is useful to understand. There's one customer here that actually on their plant, we were able to, just side note, we were able to validate this. So we had a meeting with them with 3 or 4 departments: production, industrial engineer, engineering, IT, and integrations team. And when we opened this, they all were able to, each one, relate to that. So we had the description of what the machine was doing, how the PLC was being integrated, and everyone was able to understand what was there, instead of opening a PLC, which they will not definitely understand, or a PowerPoint, which usually it's a document that gets lost and it's not attached to the project. So this replaces the PowerPoint and at the same time the code. So going into simple actions that work on the topics. So the idea here is to have actions that react to data. So if you have an action that uses, in this case, on topic input message. So every time I download it, it's going to, in a sense, pick the payload of the topic and add one. And if it is a string, it will be, if I put A, it will be A1 on input message. If it is a number, it will react upon and add a number. This is it. It's a simple topic. If I write 2, I'll get a 3. If I write 4, I'll get a 5. So very simple script, but this is where things are starting to change a little bit. You can imagine this as an input from a machine outputting to another given system, to another machine, for instance. And we are transforming it on the spot. So every time I click here, I change it, it works. So the payload, it's the trick. So we are using the payload of the topic itself. So the message that was sent on the moment and write down. If I wanted to place something like dummy response and I change it to dummy response, now every time I write on the input 4, I get dummy response. So what the Coreflux was doing there was picking up the payload, which was 4, and adding a 1. But it was changing the payload of the message. So we can use the payload of the message on any given action. This brings a new idea. This enables us to start looking at the topics as well and using the payload that we have and start to manipulate the data, not for only one unit, but for a multitude of sensors, for instance, in this case. So what I have here, it's something that we have a topic that's saying client / something / temperature. And in this case, it can be sensor 1, sensor 2, sensor 3, sensor 4, sensor 5. It can be anything that I want. What will happen in this case is that I'm using the wildcard in order to define one action that is able to run for any given type of sensor. So if I have, for instance, 10 machines that have the same mechanism to, let's say, communicate or to count, I can use an action in order to translate that into something. In this case, I'm making just a simple topics, but this with models kind of becomes powerful because it's on this point that we are able to create table schemas in order to do something. So if I upload this function and I, for instance, go and pick this here and write sensor 1, and I'm going to write 33. We have sensor 1 33, and we get something like this. Sensor 1 33, timestamp, there is a timestamp information. How? Because it's here. There is one new component. We are able to create variables that are like only running on that moment with the word set. So every time we put the keyword set, we create a variable that's temporary, that we can use all over the code. And I overlap, and you can see you are able to inject anywhere. You can even inject it on the payload, or you can inject on the creation of the topic. This way, you are using the mapping that you already have done with the broker, with the device. Imagine factory, line 1, machine 1, 2, 3, 4, 5. And you can use it for barcode readers, for whatever. And you can get the payload at a given moment and send it elsewhere. One key sentence here is with topics. I've shown you that you can get the payload, but you can also get the topic. Every time you write set sensor ID with, you can imagine that it is like equal, or you are saying that this variable will have the value of the topic, position number 2. So what we are actually putting, this is position 1, client, we are getting wherever we put on the plus. So if we put sensor ID 1, this variable sensor ID will get sensor 1. If I place here sensor 2, this variable will get sensor 2. And then we can use that with a published topic. So in here on the published topic, we are using the payload, which is the temperature that we wrote, and we are adding the sensor ID to the topic process temperature. So we are routing the information into another position. So it's like we get raw data from the PLC, we change it into something. We can even change this, and we can do a if, and imagine that we have a number 0, 1, 2, 3, 4, 5. And those numbers that we have are like enumerations of a given moment of the cycle of the machine. That 1 is idle, 2 is in production. You can transform that into strings like production, idle. So you can transform that into data. But in this case, we are only changing the topic. So we are adding the sensor ID that we received before and adding the payload, which is the 33 degrees. And then we are also creating a new hierarchy. We are putting a timestamp saying that, okay, this 33 was created at this given moment, and we have with timestamp etc. So the result, as you have seen it, it's this. If I write 33, we get this. If I have a new sensor, imagine someone goes there to the PLC, has a new sensor. Now we have a new sensor. This works for sensor 2. Someone adds sensor 44. This works for sensor 44. So you just plug and play. So the idea here is that it's already running. The logic is already running. So you don't need to kind of go into a database. No, just do the mapping the proper way. You connect the mapping the proper way, it's done. It's already running because that's your business logic internally on your broker. And this way, you're all the time able to extend your systems. So this is one of the powerful concepts that we have here. But this is only the beginning part of it. So before going to a little bit further, any questions regarding this?
In the topic position, we put any valid value like -1 or 0. Does the topic give us the error? Is this hidden?
No, what happens is that on every given any given message action that you provide, the action will not conclude. So it's not able to fetch the information that you are required, so it will not run. If you go to the log of the broker, which you can actually use the UI for that, you will see an error message on the log, on the broker log, saying that the action was not able to conclude. In here I was trying to remove an action and I got this. Every action, which actually is a good question, every action that is not able to run, if you don't have the topic position right, like you were saying, you will get the information here. Another thing that was probably, if you use, because you are able to also, I will show you another concept, you are also on a given moment, imagine we have a sensor of temperature, right? That occurs like this one, and you want to get another information that is on another topic, you're able to do that. You're able to have. But if the information is not there and it's no, if it is important to publish, the action will also not provide any information. So it will not conclude. So for Coreflux, it's important that this concept of inputs, effects, output, it's on their minds, because if the inputs are invalid, like the one that you were saying, our PLC will protect the customer of execution. So the execution will not occur because the input data, it's not valid, let's say. So in the end, what we get is an error message saying that it's not running. But the topic position is also code. It means that you did the wrong code, unless if it's a get topic. On the other one, we saw the topic position, we saw the set variable, we saw the publish, and this one is the same thing, just it has more data. So what we are actually doing here, it's like, imagine you have a factory and you want to build a notification system, and you have all your alarms, and you have the lines and the machines, and by some reason you require to create some contacts, like when the alarm occurred, and also you want to send this to a dashboard, to another dashboard. Imagine that you have two systems. You have the alarm notification system and you have the dashboard. So you're not only sending data to one system, you are sending data to two systems. So you can imagine this one like a TV that has all the information of the plant, and every time on the dashboard alarms latest an alarm occurs, it will populate that alarm on a window. If I upload this one, and you can see that we are fetching the line ID and the machine ID. So this will work for every line, for every machine, as long as we are providing the alarm topic. So we need to provide this alarm topic, that one. So that is the rule that we need to have in order to run this action. If it was not contextualized, you can imagine that we had another action in order to get from, imagine you have like a robot, and robot sends the number for each alarm, okay? And you have define alarm action for robot number 1, and you put an if payload equals to 1, then publish this topic, else publish this topic, else publish. So you can provide the names of the alarms, and you have an action that integrates robot 1 with the alarm system that you have on your factory. So you transform numbers into text. And if you have this function, this action, you already have the alarms of robot 1 going to the dashboard and also to the notification system. And if you add another robot, which is robot number 2, and the names are different and the numbers are different, okay, you create an action. But if it's a CNC, it's probably different. The alarms come from different variables, so you also create an action for that. So you are able to do an integration of raw IOs on any given action, which is the place where you do a mapping, and you have the standard system using this type of actions that define what is like the standard, the way you work. So in this case, we already have the alarm. So imagine if I write overheating detected, boom. I get three structures. One was the machine providing the alarm. Another one was this line 1, machine 1. This is what I want to write. This was the definition of the guy from IT that defined it. They want it like this. And I also have this on the dashboard. I don't like the tests that I have here. Okay, just go here and we can change this like this. I'm writing machine, so probably what I will do is I will stop writing machine. We can have like numbers. I will publish on the topics actually. So I can go like line 1, machine 1, overheating detected. And I can even go to line 2 and say pump failure. If you go now to this, you have these two alarms, but you also have this contextualized here for a database. And this could be transformed into a model, but this is the only message that you get on the dashboard because it was the last alarm that was received. So in this action, we are only publishing the last alarm that occurred. We can see it here. We are getting the line ID, we are getting the machine ID. So line ID is topic position 2, which is this one. Machine ID is this one. And then we are creating a text, simple text saying line and the number of the line, machine and the machine. So this is the text we are using for the dashboard, which is here when we publish the dashboard. And at the same time, this one is used on the variable context that we are creating for this alarm factory and also the timestamp. So the idea here is to show that you are able to route the data to any given system. And if you have, for instance, and it is very important and it is something critical, you can also add here like routing to stop anything. And you can put a if, saying if it's line ID 1, machine 1, because it's a critical component of the plant. You can also put it here or on another action. It will depend on the system what you want to build. But you can understand that this works like a chain of events. One event occurs, this runs. And if you publish something, it can create another event and it creates other events like a chain.
Earlier you said that when you get an event, you create like a snapshot of all the data. So my question is, in this case, do you get a snapshot of before and after? So that, for example, if I request some machine to stop, do I know what happened first and like?
Yes. If you use the get topic, you can check what was the information before. And then if you change during the execution, it will already be with a different value. So imagine you can say if get topic robot status equals to true, something like that. Then do this, else do that. You can do that. But in this case, you only have the payload here. You have the picture of alarms, factory, line 1, etc. But we are only publishing. We are not collecting. So that occurs, like you were saying. But in this method that we are running here, the only topic that you are actually collecting, it's the one using payload, which is the topic itself that occurs.
So that's the only snapshot we have?
Right now, yes, the only snapshot. But if we use get topic, we are defining another input because you only have publish. Publish, you are only publishing. Get, you are reading. It's an input in the end. And actually, that will be the next one that we go below. But I'll go on that one. Once we get to get topic, I will go back to that one and explain what happens. So this also gives us a possibility of having transformation. So in this case, what we are doing here is transform from Celsius to Fahrenheit. So we are changing the data from one type to another one. And the explanation is quite simple. We use the same concept. We have the topic position over there. We already have the payload because it comes on Celsius. This is like direct math to change to Fahrenheit. So it's multiplying by 9, dividing by 5, and adding 32. We could use a factor, but it runs first the multiplication, then it divides, then it adds the 32. So it uses the same concept as you can see on the PLCs. First it runs the multiplication. Actually the first layer to run, it's the parentheses. So if you have it under parentheses, it will run that one first. Then if you multiply, it will run, or divide, it will run that one first. And then it will only provide the addition or subtraction. So this one, if I copy and put it like sensor 1 and I put 33, we get this. We get Fahrenheit with the count, we get a string with both, and converted at this time, where you can see it here. So this is where we are doing the math. Okay, this is where we are getting the sensor ID, this is where we are doing the math, and this is actually changing the publication of creating the conversion of Fahrenheit. And the one with both, it's creating again a string with both values. So you're able to put both values, and just a quick topic saying when it occurred and what we are doing. So more or less, this is the concept of actions with topics. You're able to really use the wildcards. You can go very deep with the execution, because you can really fragment in what you want to do. We kind of will have now a short break. Just going to cover in 2 or 3 minutes the beginning of one logic, just to answer your question. So you see the get topic here. So what we are doing here, we are publishing another topic with, on the moment test topic occurs, we are publishing another topic. So if I publish something on test, it will get the topic counter value and copy to topic 1. So this will only occur if I write something on the topic test, okay? And it will happen, it will do what you were saying. It is going to collect a picture of counter value on the moment it occurs. And counter value, as you can see, it's all the time changing, it's incrementing. So on the moment I write on topic tests, it will collect a picture of counter value, because it's an input inside the logic to show the test. So I can write wherever, because I'm not using the payload. So you see alert. If I click, it's running several times, but it's collecting the information. If you see here, every time I click, it is writing the number that it has in memory. So it's really taking the snapshot. The button is running away from me, so it's quite hard. But you can see that I have a lot of message over there with the same value. So it's collecting the value, taking the picture, processing the function, and outputting the function. You can see it here. 227, then it goes to 2279 because I stopped at clicking. But you can see that several times I was clicking with my mouse and it was on 2280. Then I click it on 2281. So it's collecting the topics because I define it on the moment of test to collect the information. I could have done this on every second, but it was not going to create this idea of I'm collecting on every time the topic test is occurring, which was done by this mouse while clicking the button. I don't know if this answers now your question that you had.
Kind of. My question, my doubt is, if I know what might cause the failure, it's okay for me to program it to collect the information. But in cases where I do not know that X sensor is going to cause X failure, then I cannot write the code to get the snapshot of that.
But you can do something, which is you can create another topic, like you have if, else if, and you don't know what to do with this data. You can create a topic that you log, and then it goes to a database that something occurred. That's very common, actually. If you don't know what that's, especially the guys from dealing with REST APIs, when they are transforming webhooks that occur, that they don't know what is happening, they create a route for a database or for a file, and they they store, because you don't know when that is going to occur, when a line is running. It can be now, or it can be in 3 days, or in 10 days. But at least you get a message with the payload that this occurs at this time. It was triggered by robot 1, and it had this payload and this given message. And you have it on the table, and then you look at it, whoa, what is this information? And you can then act upon it. Yeah, but so you get the snapshot. This is going to be useful when you build the models. So maybe now we do a very short